Today we are going to solve Cambridge O level paper ATP 5054 October number 2022 paper 4 variant 1. Question number 1. A student measure the refractive index of oil. Oil is poured into a semicircle transparent plastic container as shown in figure 1.1. So we have placed our oil in plastic container. The container is placed on the top of a 360-degree protector as shown in figure 1.2. This is your figure 1.2 in which you can see that it is placed on a protector. The line AB shows the position of the flat side of the plastic container. This is your line AB, and a ray of light is incident at the midpoint of AB with the angle of incidence I is equal to 30 degrees. So your angle of incidence will be equal to 30 degree, the angle with the normal. State one property of the oil that is needed to ensure that the experiment works. If our oil is opaque means that light can pass through it. Opaque light can pass through it. Then we can see the refraction. Otherwise, you cannot see the refraction. So our oil should be opaque or light can pass through it. Part 2 on figure 1.2 measure the angle of refraction of the light. For the angle of refraction, this is our angle of refraction R. From here I can see that if these are equal to 30 degree, which is given that in angle of incidence is 30, so total 15, 5, 10, 15, so 15, 30 divided by 15 equal to 2. So your one line is representing 2 degree. So here 5 and 5 mean tens, so 10 mean 20 and 1 half for the half of the 1 point, so it will be equal to 21. 5 plus 5 plus half, it will be 11.5. 11.5 multiplied by 2 will be equal to 21. So angle of refraction is 21 degree. The student repeat the procedure described in A and measure the angle of refraction R for the angle of incidence 15, 45, 60 and 75. The results are shown in table 1.1. Complete table 1.1 with the value of R from A2, and it is 21 degree. Now on the grid provide in figure 1.3 a graph of R on y-axis, and against I on x-axis. I on x-axis start from 0, 0. So it will start from 0, 0. Now first of all we are going to give the values to our x-axis and y-axis. For our x-axis we have to move till 75. So okay, giving the values to our x-axis and y-axis, I am going to zoom our graph, and it will be for x-axis it will be this 10, then 20, 30, 40, 50, 60, 70 and the last 80. For y-axis it will be 10, 20, 30. Every single block is given the value of 10 degree. 30, then 40 and 50. Now I am going to minimize a little bit so we can draw our points. First point is for 15 of x-axis, 11 of the y-axis. So 15 will be between 10 and 20, and 11 on the x-axis will be over here. Y-axis 11, x-axis sorry, 11 below, little bit below from that, 11 and 1 2 3 4 15, 11 and 15. The second one is 30 and 21, 30 and 21. Third one is 45 and 31, 45 and 31. Then 60 39, 60 and 39. Then the last one is 75 and 45. So 75 and 45. 45. So I'm going to mark points over here, at here. All the points are being marked. Now draw a smooth curve. So for the smooth curve, it will be like this one, a smooth curve. For the curve, you don't have to draw a straight line. Now, describe the relationship between, after drawing the table, you have to describe the relationship between I and R. From here, I can see that it is a direct relation. The values of I increases as R increases as I increases, because R depend upon I. R increases as I increases. As we increase our angle of incidence, the angle of refraction also increases. Use your graph to find the value of R when I equal to 50. So when I equal to 50, which will be over here, what is our value? Our value is approximately 34. So 34 degree will be the value of R if I equal to 50 according to our graph. Theory suggests that the refractive index n of the eye is given by n is equal to sine I over sine R. Use I and R in B3, where I is 50 in B3 and R is 34. Now n will be equal to sine 50 divided by sine 34. By using calculator, sine 50 divided by sine 34 will be equal to 1.369. So your refractive index will be equal to 1.369. In part 5, on figure 1.4, sketch the graph where sine R is plotted against sine R. No calculation are required. We know that it should be a straight line because n is constant. N is constant, so it should be a straight line between sine R and sine I, because n is the ratio of sine I over R, sine R, and it is always constant, so it should be a straight line. Suggest one reason why the practical method used in this investigation might not give an accurate value for n. Because of reflex error, measuring the angle of incidence and angle of reflection could cause the error, or there is some refraction due to plastic box or plastic container. There is also some refraction due to plastic container, due to which our results could be a little bit inaccurate. Now question number 2. A student investigate the cooling of water. The apparatus used in is shown in figure 2.1. It's a 500 centimeter cube beaker and a 250 centimeter cube beaker. Then a thermometer and a stop clock. The student poured 200 centimeter cube of hot water into the 500 centimeter cube beaker. Places the thermometer in the water, stir the water, measure the initial temperature of the water, then using the clock to find the time taken for the water to cool by 5 degrees centigrade and by 10 degrees centigrade. Repeat the experiment 3 times. Explain the water is stirred before taking a temperature reading. Why this is why we are going to stir before taking the temperature? To make even temperature. To make temperature even in the container. Even in the container, so that all the water is on the same temperature. The student uses 200 centimeter cube of hot water in the same beaker in each test. State one other experimental variable that the student keep constant to make a fair comparison of the 3 sets of results. Now liquid is the volume of liquid is same. The other things should be the initial temperature should be same, so that our result should be same. Or we can say that room temperature. Due to change in room temperature, our result would give different answers. Table 2.1 shows the results obtained by the student. In trial 1 it will be 82 for 5 degrees centigrade and 173 seconds for 10 degrees centigrade. Trial 2 84 for 5 and 184 for 10, and 82 for 5 and 185 for 10 in trial 3. So the average time is calculated for trial for 10 degrees centigrade, and it is 181. Complete table 2.1 by calculating the average time taken for the water to cool by 5 degrees centigrade. Give your answer to approximate number of significant figures. To calculate the average, we are going to add 82 plus 84 plus 82 divided by 3, and it will be equal to, by using calculator, 82 plus 84 plus 82 whole divided by 3 will be equal to 82.67. So we are going to get our result in two significant figures, because all the other quantities are two significant figures. So it will be 83, because 82.67 mean it is greater than 82.5, so it will be 83. Suggest one reason why the time taken for the water to cool by 10 degrees centigrade is not double the time taken of water to cool by 5 degrees centigrade. Why this happened? This is because more temperature, more hot liquid lose more energy. More hot liquid is going to lose more energy. Or you can also write that smaller difference from the room temperature. For 10 degrees centigrade, the difference between the room temperature and 10 degrees is smaller, while for 5 degrees centigrade the difference is larger. So there is a difference between the smaller difference between the room temperature could be the reason that it is not double the time taken for the water to cool to 5 degree centigrade. The student repeated the experiment using the 250 centimeter cube beaker. All the experimental variables remain the same. Table 2.1 show the average time taken for 250 centimeter cube and beaker to cool by 5 degrees centigrade and by 10 degrees centigrade. For 5 degrees centigrade it is 110 seconds and for 10 degree it is 250 seconds. Describe the difference in the cooling of water in the two beakers. Refer to the results recorded in table 2.1 and table 2.2. I am writing the average temperature. This is for 250 centimeter cube beaker and for the 500 centimeter cube beaker is 83 and 181. 83 and 181. For 500 centimeter cube beaker it take less time to reach room temperature. It take less time to reach room temperature. Okay, suggest a reason for the difference. Very easy. The surface area. For 500 centimeter cube beaker, the surface area is more than the 250 centimeter cube beaker. Question number 3. A student measures the density of a sample of modeling clay. The clay is molded into a cube as shown in figure 3.1. Suggest one difficulty the student find when molding a clay into cube. To make all sides equal and straight. It is difficult to mold the clay and make all sides equal and straight. On figure 3.1, measure the length D of one side of the cube. You have to measure this by using your scale, and by scale it will be equal to 2.4 centimeter. Now calculate the volume V of the modeling clay using the equation. So we are going to take 2.4 cube and 2.4 cube will be equal to 2.4 cube will be equal to 13.8 to 4. So it will be the volume of the clay. The student uses a balance to find the mass m of the modeling clay as shown in figure 3.2. Calculate the density of the modeling clay using the equation P is equal to rho is equal to m over v, density is equal to mass per unit volume. Give the unit of your answer. Now mass will be equal to 36.3 and volume will be equal to 13.824. So 36.3 divided by 13.824 and it will be equal to 2.625. So I am writing 2.63. Unit will be gram and centimeter cube. So gram per centimeter cube. Last question, question number 4. A student investigate the current in a resistor of fixed resistance. The following apparatus is available. Ammeter is available. Electrical connecting leads are available. A resistor of fixed resistance, lamp, switch, variable resistor, 6-volt battery, LED and voltmeter are given. Part A. State which piece of apparatus is used to measure current. Ammeter is used to measure current. Ammeter is used to measure current. The student measure the current I for the range of potential difference. Current against potential difference. Draw a circuit diagram to show the circuit the student use. You may use all or all the apparatus available, some or all the apparatus. So first of all I am going to use my battery, then switch, then I am going to connect my ammeter over here to find the current in the circuit, then the variable resistor, then the resistor or the lamp, fixed resistor or the lamp. then it will be close with the battery. Now against the variable resistor or the lamp, you are going to connect the voltmeter. Okay, you are going to use only the resistor because we are going to investigate resistance of a fixed resistor, so we are not going to use lamp over here. So voltmeter against the resistor and ammeter to measure the current every time. And variable resistor is used to change the value of current in the circuit. As the current changes, the variable resistor voltage changes, so voltage against the fixed resistor also changes. Describe how the student obtained different values of the potential difference across a fixed resistor. Very easy. I have discussed it by changing the resistance of variable resistor. By changing the resistance of variable resistor, we can change the potential difference across the fixed resistor.